Welcome back, and this is Fahad Rifai. I'm going to show you how to get a username in for this free tool called HelioScope. You just go to type this on your browser, and after that you will find this page. Actually, you can have sign up for a free account, but if you already have one, you can just log in. Let's start and try to make a new free user by clicking here, sign up. Don't worry about the subscription fee here. This is if you want, but if you want to try, you just have to enter your data. After that, you get a password, and then you check this box and sign up. After you do this, you will be receive an email from HelioScope, and you have to click in the URL they send it to you to activate your account. Because I already have one, or because I already have an account, so I'm going to log in as an existing user. So all I have to just sign in, and the first thing you will find is this screen. This screen show you different sections. I will tell you or give you uh, everything about this. First thing is this is here called sign up now, because this is just a trial period and expires in a month. So if you want to sign up for a paid one, you can just click here and update your free account to paid account. However, we are not going to through this. I will go to show you how to start your first project and how to go through designing and of the whole system. However, in the upper right, you will find this icon. It's called libraries. You just found different sections. You have modules, inverters, optimizer, you have wires, and you have meteor files. However, when you click, for example, on module, you are going to find the whole different types of PV module in this tool, and you can just click any one of this and see the details and see the specs. This is just a data sheet for each PV model, and it's very nice. It gives you all the data you can ask. You can find it in the real data sheet. For example, this big sheet tell you the maximum power of this module. It said it's 160, and it's polycrystalline, and the manufacturer is 3Sun, and this is the power. This is the name of the module or the panel. This is the Pmax or the maximum power, but this is the voltage at the maximum power, and this is the open circuit voltage, the short current, and the current at maximum power point. This panel or module, it consists of 48 cells, and as we said, it's polysilicon, and you will find here different, this is the dimension, this is the coefficient, temperature coefficient for all parameters. However, you can find more details in the figure and the graph here. This graph, it tells you the different output, the different power, the different current and voltage at different irradiance. This is the irradiance here. It's 1000 watt per meter square. This is the blue one, and it tells you at each point what is the voltage and the current, and of course if you multiply these two values you will get the maximum power at that time. So this is just the data sheet of your model, and you just go through all the model and you find your the best one for your designing. However, we can search by using the manufacturer. For example, if we search using SunPower company, so this is manufacturer and this is the rated power and of course the voltage and current. Or you can, if you know the name, the exact name, you just type for example 160 ND. If there's nothing like this, but if you just put 160 watt, there's no, but you can remove the manufacturer here, and when you type the module name, you will get this the result here. So you can change the type of the material if you want to use silicon, mono or poly, or candium, indium, selenium, or any others thin types. Okay, now let's go to find the others. The second section is about inverters and optimizer, and it's the same thing. For example, if you are looking for the exact name for an inverter, I know this one is very famous for PV installer. It's called Sunny Boy from SMA, and this inverter is showing here. It has two types. One is 2 kilowatt and the other one is 10 kilowatt. Okay, now let's skip this and go to the home screen and discover the other buttons here. This is very important icon here. It's called the new project. If you click this, you have to do some filling in. For example, this project name, I will say it's let's say it's PV or home at PV or PV at home, sorry, PV at home. Okay, let's decide what is your exact location. I will type a certain city. It's a famous city in Saudi Arabia. It's called Jeddah, and I just going to pick up any building here. I hope it's suitable um, for our teaching, but because the resolution here is not fair enough, I will move to type any location in the USA. Let's say USA. This is USA. I will check any building on any suitable building here. For example, this one. It seems very nice and very flat. It seems like flat, yeah. And let's suppose the profile is for a residential building, and you can type here anything in description. We are not going here. Then after that you have to click create new project. If you see now, you go to the other different screen. This screen actually show the name of your project you have just created, and the location, of course, in the USA, and some overview about your project. Then you have to go to the first section, it's called designs, and go to new design. Let's see, design number 1, create. After that you will find your design is here, and this is our location. You can also change the location, but now we are going to focus in this place. However, here we find you have two buttons, one called mapped, the other one called SLD, or single line diagram. This will show you how your components, the PV model and inverters and other wires, wiring and everything, how to connect to each other. But now it's disabled because you haven't done any design yet. First thing, you have to determine the area you want to build your system on it. So go far and to the mechanical part here in the left, then go to new, and when you click in the new and you move your mouse pointer, you will see a green point for your mouse. Just click once and now just click in the corner and lift and move. Another click, one more click to determine the area, and go back to the start point. Now, as you say, the area is already determined, but you haven't choose your model yet. So he will tell you to choose a module. Select a module. I always try to get, for me, I love to use 300 watt module, or you can use just 250 because it's very common. I'm not going to choose a certain manufacturer. We just pick up one of them. But if you know the manufacturer, you can just type the manufacturer and you will get the whole module. So I will pick up, for example, this one is Soltec 250. Now you see that the area you determined has covered with PV panels. Here in the up, you find this button say showing array. If you just click, the array will be hidden. See, click again, showing array. You can zoom in if you want. You can move and zoom in, and this is your array, as you say. Now, what if you want to make a path between this array? It's not good to make the whole area covered by panels. So go now to keep out and just determine any place you want to remove the panel from, just like this. I will show you now. I will make a small path, just like rectangular, with certain. Now, as you say, there is no panels in this path. It's automatically removed. Okay. What about if we have some near building and we want to discover the shadow? For example, this tree here. So I will go to keep out bottom and I will try to determine the area of the tree, or it seems mini trees, different tree. I will just take this one, just make it as a one big tree, and I will finish by something like this. But if you click here, see like this, you'll see this is not what you want to have. See here, the tree is showing just like a flat. So how to deal with this? You go to K out 2 here, and let's do something like 10 the height, like 10 meters. This is how it looks. And now let's go to the mechanical one and determine as the fill segment here, and determine the type of racking, because here I have chosen the flush mount racking, but if you want you can use the fixed tilt. That will make it just ground mounting. What if this is just a building? In this case you have to determine the height here. Let's say it's one floor building, 4 meters of height. This is how it looks, and if you find, this is how it looks. So if you can see with me, this building here is not actually the shadow is away from the building we are using to build our system on it. This is just by chance, and you can find this view, and if you want to recenter the view, just click here. So this is your view. If you have different building around you and you want to determine him to study the shadow, so you just do the same what we have done in this tree. Okay, now let's moving to the second step, which is the electrical zone. And here the important thing is to determine the inverter. Before that, if we go back to the mechanical one and choose find the segment number 1, the determined area we have done is just it will generate about 21 kilowatt of PV system, or actually we can build a 21 kilowatt of the PV panel, and this is the only panel you can place in this area. Okay, now let's move to electrical zone and choose an inverter. As we say, it's a 21 kilowatt, so we have to try to use or to choose an inverter with the same size. So let's say if we have 21 kilowatt, there's no 21 kilowatt, so I choose 25 kilowatt if there is. Yes, I got one. It's called Fujian New Sun Power Energy. It seems like Chinese inverter. If you want to use this, but if you want to use a certain name like Sunny Boy, here we have 2 kilo and 10 kilowatt. So if you choose 10 kilowatt, in this case, the program will tell you that you need 2 of this inverter. Why is this? Because this is only 10. So 2 times 2, this is the total will be 20 kilowatt, or almost more than 20 kilowatt, because our panels is 21 kilowatt. So when you choose this, you will get here the count 2, and also you will see 2 samples for inverter AC/DC. This is 2 circles, and this is showing just the 2 inverters. What about this small square? This is just the combiner for each group. Now go to SLD, or single line diagram, and you will find a very nice drawing for your system. If we go to start with this one here, here is first group of your system. It has 2 strings count, sorry, it's 3 strings. Each string has 13 panels or module. The total is 39. These 3 strings they will combine in one combiner, 3-circuit combiner, and after that it shows also as well the size of the DC cable from panels to the combiner. It's 10 odd AWG, or American wire gauge. It's copper, it's not aluminum. You can change this later. After that, you will go with 2 AWG copper to the circuit combiner. After that, you will go to the disconnector, and this disconnector is just the DC disconnector because we still here in the DC side before the inverter is converted to AC. This is the AC. The other groups here we'll see in the map. This is the first group, this is the second group. The other group is 4 strings with 11 module in each string, and these 4 strings they combine in the 4-circuit combiner, and they go out with 1 combiner and to the second inverter. So here we have 2 Sunny Boy 10 kilowatt inverters, and the output of each inverter they go to the interconnection, and to the AC disconnector, then to your surface panel at your house. And of course, you can distribute the power you get from PV to your home appliances or loads, or you can use a meter and connect it to the grid as an on-grid system. You can see here the trunk. It said it's 500 MCM copper, or you can change it from any of this shown here. The home runs cable and the number of poles, combiner poles, and the target